at number 2 on our related rates problem homework set. So if you read number 2, it's talking about a volume of an expanding sphere. So we're going to start with our drawing. The drawings for this one's not so helpful, but we will follow suit and just make a drawing of a sphere. Okay, now we need the rates. So if you take a look at this problem, it says the volume's increasing at a rate of 12 cubic feet per second. So dV over dt is equal to 12 feet cubed per second. Alright, then they're asking us for how is the surface area increasing. So that's dA over dt equals what? We don't know what it is, but we're going to look for it when the volume is 36 pi. Okay, now this A is area, not angle. Alright, equation for the volume of a sphere, you will eventually have this memorized. That's 4/3 pi r cubed. We're going to differentiate that using the power rule, so dV over dt equals, when you bring the 3 down, that's going to cancel with the 3 on the bottom, so you really just have 4 pi r squared dr over dt. Alright, now we're going to substitute, but we got to figure out if we're missing any values. So we have dV over dt, we're missing a radius. So we need to find the radius when the volume is 36 pi. So we're going to plug that in here. So we're going to write substitute and solve. Okay, but we need to find r when the volume is 36 pi. Okay, so 36 pi, we're just plugging into this equation up here, equals 4/3 pi r cubed. Okay, so you're going to divide both sides by 4/3 pi, divide by 4/3 pi, and you're going to get that, let's see. You know what? We can do it that way, but I'm going to actually write this out a different way to show you the simplification's not as hard as it looks. You have a pi on both sides. Whoop, both those pi's cancel. Okay, so if you divide both sides by 4/3, you're going to get 27 equals r cubed. Take the cube root of both sides, r is equal to 3. Okay, now we're ready to substitute. So we're going to go back to our derivative. We know that dV over dt is 12. So 12 equals 4 pi, and we're going to use this radius of 3. And we're still looking for dr over dt. That's what our question... Well, actually our question mark is area, but what we're solving for right now is radius, and then we'll use that eventually to help us find the area. So just kind of roll with what you have and see what you end up with, and then from there, if you're not sure what to do, you can kind of figure it out from that point. So we're solving for dr over dt now, so we need to divide both sides by 4 pi times 3. 4 times 3 is 12. So these kind of cancel. You basically end up with, wait, I feel like there's an error here. Aha, did you catch it? This should be squared. So 12 is actually equal to 4 pi times 9 times dr over dt. Okay, so 12 is 36 pi dr over dt. So dr over dt, if you simplify, it's going to be 12 over 36 pi, which is 1 over 3 pi. You can find the approximation of that, but we're going to leave it just like that. Okay, so we solved for dr over dt, but that's not what we're looking for. So we got to go back to the drawing board. Do we know an equation for the surface area of a sphere? Well, in fact we do. Maybe you don't remember it, but there is such an equation. So sorry, I had to draw a line there. So let's go back to the equation step. So the equation for the surface area of a sphere is 4 pi r squared. Okay, so we got 4 pi r squared. Now we got to differentiate. So we're following our same steps. Okay, kind of a second part here. So we're going to differentiate both sides. We get dA over dt equals 8 pi r dr over dt. Okay, we're making headway here. This is what we're looking for, if you remember, all the way back up here. And we know the radius, and we know dr over dt. So we're actually good to go. We're going to go over here and substitute. Okay, so dA over dt is what we're looking for. Is equal to 8 pi, our radius. If you look back up there, our radius was 3. Times 3 And then we just solved for dr over dt here, so that's 1 over 3 pi. Now this simplifies really nicely. Okay, so our 3's cancel, pi's cancel, we end up with 8. If you think of our units, we're looking at area, so that's, in this case, we were doing feet squared per second. So what we would say is the surface area of the sphere is increasing at a rate of 8 feet squared per second when the volume is 36 pi.